Hello and welcome back to AI Pulse Trends, your channel for navigating the exciting, ever-evolving world of artificial intelligence. Today we're embarking on an incredible journey, not just into the future of AI, but deep into the human past. Imagine walking through the bustling streets of ancient Rome, hearing the chatter in the marketplace. Imagine deciphering the mysterious script of the Indus Valley civilization, unlocking secrets lost for 4,000 years. Imagine seeing the full glory of a Mayan temple complex, not as crumbling ruins, but as it stood centuries ago. For generations, reconstructing these lost worlds has been the painstaking work of archaeologists, relying on fragmented pottery, eroded inscriptions, and educated guesswork. It's like assembling a universe-sized jigsaw puzzle with most of the pieces missing, faded, or broken. But what if we had a new tool, a tool capable of sifting through mountains of data, recognizing patterns invisible to the human eye, translating languages we barely understand, and even generating plausible visions of what might have been? That tool is artificial intelligence. Today, we're diving deep into the fascinating intersection of AI and archaeology. We'll explore how sophisticated algorithms are becoming indispensable partners for historians and archaeologists, helping them piece together the narratives of civilizations that have long since vanished. We'll look at the specific AI techniques being deployed, the breakthroughs they're enabling, the significant challenges that remain, and the truly mind-bending possibilities that lie ahead. Are we on the verge of digitally resurrecting lost worlds? Can AI truly help us understand our ancestors like never before? Stick around as we explore how AI is becoming the ultimate archaeologist's assistant. So, why is reconstructing lost civilizations so incredibly difficult? Let's break down the core challenges archaeologists face. First, there's the scarcity and fragmentation of evidence. Time is not kind. Organic materials decay, stone erodes, structures collapse, records are lost to fire, flood, or conquest. What survives is often a tiny, scattered fraction of what once existed. Trying to understand a complex society from a few pottery shards and foundation stones is immensely challenging. Second, interpretation is complex and often subjective. How do we interpret symbolic art? What did specific burial practices signify about social structure? How do we translate languages with no known relatives or Rosetta Stone? Historical accounts themselves can be biased, incomplete, or written by outsiders. Traditional methods rely heavily on human expertise, which is invaluable but also limited by individual knowledge and potential biases. Third, the scale of data can be overwhelming or frustratingly sparse. Modern archaeological techniques like LiDAR scans, ground-penetrating radar, and satellite imagery generate vast data sets that are difficult for humans to process manually. Conversely, for some crucial questions, like the meaning of certain symbols or the specifics of daily rituals, the available data might be almost non-existent. This is where AI steps onto the scene, offering powerful new ways to tackle these age-old problems. AI isn't replacing archaeologists, it's augmenting their abilities, acting like a tireless digital assistant with unique cognitive skills. At its core, AI excels at pattern recognition on a massive scale. Machine learning algorithms can analyze thousands of pottery fragments, satellite images, or textual snippets, identifying subtle similarities, anomalies, or correlations that might escape human notice. This could involve classifying pottery styles to track trade routes, identifying potential archaeological sites from terrain data, or grouping inscription fragments based on linguistic patterns. AI is also revolutionizing data processing and visualization. Think about reconstructing a collapsed building. Using techniques like photogrammetry, creating 3D models from photos, combined with AI, we can scan thousands of fragments and let the algorithm suggest how they might fit together, generating detailed 3D models of the original structure far faster and sometimes more accurately than manual methods. Computer vision algorithms analyze aerial and satellite imagery, automatically detecting faint traces of ancient roads, field systems, or building foundations hidden beneath vegetation or soil. Another crucial area is natural language processing, NLP. This branch of AI deals with understanding and generating human language. For archaeologists, NLP offers hope for deciphering lost scripts. By training models on known languages and scripts, AI can identify statistical patterns, potential phonetic values, or grammatical structures in undeciphered texts, providing linguists with new hypotheses to test. It can also analyze vast digital libraries of ancient texts, identifying connections, themes, or shifts in language used over time. And then there's the exciting, sometimes controversial field of generative AI. Models like GANs, generative adversarial networks, or diffusion models, famous for creating images and text, can be used to generate plausible reconstructions based on incomplete data. Imagine feeding an AI all known data about Roman house architecture, layouts, materials, decorations, and asking it to generate a visualization of a typical Roman villa's interior, filling in the gaps based on learned patterns. This isn't definitive proof, of course, but it provides archaeologists with testable hypotheses and powerful visualization tools. Finally, AI enables sophisticated simulation and modeling. Archaeologists can use AI-powered agent-based models to simulate ancient societies. By inputting data about environment, resources, known social structures, and potential behaviors, these models can explore how populations might have grown, migrated, interacted, or responded to events like climate change or conflict. This helps test theories about social dynamics, economic systems, and the factors that led to a civilization's rise or fall. Let's zoom in on these key AI techniques powering the digital dig: machine learning, ML. Think of this as the pattern finder. ML algorithms learn from data. In archaeology, they classify artifacts, like telling different pottery types apart instantly, predict where sites might be hidden based on landscape features learned from known sites, and find subtle correlations in large data sets, like linking tool types to specific time periods or locations. Natural language processing, NLP, this is AI for language. It's crucial for analyzing ancient texts, identifying linguistic patterns, comparing unknown scripts to known ones, and potentially suggesting translations or phonetic values for symbols in lost languages. It can digitally read and categorize vast archives of inscriptions or documents. Computer vision, AI that sees. This analyzes images and videos. Think satellite or drone imagery, where AI spots faint outlines of buried walls, or using photos, scans of broken pieces, where AI suggests how they fit together for 3D reconstruction, photogrammetry enhancement. It can also identify symbols or features on artifacts from images. Generative AI, the creator AI. Based on existing data and learned patterns, these models can generate new content, plausible reconstructions of how a building might have looked, what textiles might have featured, or even hypothetical faces based on fragmented statues or descriptions. Great for visualization and hypothesis generation. Simulation and modeling, InKL, agent-based modeling, ABM. Creating virtual worlds, inputting data about environment, population, resources, and known social rules allows AI to simulate how a society might evolve, migrate, trade, or collapse under different conditions, like drought or conflict. ABM specifically simulates individual agents, people, households, and their interactions. Now let's see these tools in action with some concrete examples. Lost scripts are one of history's greatest enigmas. While AI hasn't single-handedly cracked scripts like the Indus Valley script or Linear-A, the script of the Minoan civilization, yet it's providing powerful assistance. NLP models can analyze the frequency and position of symbols, compare them statistically to known languages, and identify recurring patterns much faster than humans. Researchers at MIT and Google's AI lab have worked on systems designed specifically to help linguists by suggesting potential relationships between ancient languages or proposing phonetic values for unknown symbols based on patterns learned from vast linguistic datasets. It acts as a hypothesis generator, pointing human experts in promising directions. Imagine walking through Teotihuacan or ancient Athens as they were in their prime. AI is making this increasingly possible. LiDAR, light detection and ranging scans from drones or planes, can penetrate jungle canopies or map vast landscapes. AI algorithms then process this point cloud data to identify subtle archaeological features invisible from the ground. Teams have used this to discover thousands of previously unknown Maya structures hidden in Guatemala. Furthermore, computer vision and machine learning analyze these scans along with photos and architectural fragments to create highly detailed 3D reconstructions. Projects like Virtual Rome use procedural modeling guided by AI and historical data to generate vast, immersive digital models of ancient cities. Generative AI can even populate these models with plausible details. Textures, decorations, even virtual inhabitants, based on archaeological finds. AI is helping us move beyond just kings and monuments to understand the daily lives of ordinary people. Machine learning algorithms can classify tens of thousands of pottery shards based on subtle variations in shape, material, and decoration. This can reveal patterns of production, trade networks, and even social stratification within a settlement. For instance, analyzing the chemical composition of pottery with AI assistance can trace its origin, mapping out vast economic interactions. Agent-based modeling, powered by AI, allows researchers to simulate what-if scenarios. What happened to the Anasazi people in the American Southwest? Researchers can model population dynamics, agricultural yields based on reconstructed climate data, paleoclimatology, and resource depletion to test theories about migration and societal collapse. These simulations don't give definitive answers, but they help evaluate the plausibility of different explanations. Where should archaeologists dig next? AI can help prioritize exploration by training machine learning models on data from known archaeological sites, including terrain type, proximity to water sources, soil composition, satellite imagery features. AI can predict areas with a high probability of containing undiscovered sites. This predictive archaeology saves time and resources, focusing excavation efforts where they are most likely to yield results. This is already being used in regions from Egypt to Peru. Now, while this all sounds incredibly promising, and it's crucial to acknowledge the significant challenges and limitations of using AI in archaeology. This isn't a magic wand that instantly reveals the past. The first major hurdle is data quality and availability. AI models, especially deep learning models, are data hungry. For many ancient civilizations, the available data is sparse, fragmented, and uncertain. Feeding incomplete or poor quality data into an AI can lead to inaccurate or meaningless results. The classic garbage in, garbage out problem. How do you train an AI to recognize Mayan art styles if you only have a few eroded examples? Second, algorithmic bias is a serious concern. AI systems learn from the data they are trained on. If that data reflects historical biases, for example, focusing only on elite burials using texts written only by men or victors, the AI's conclusions can perpetuate or even amplify those biases. Furthermore, the algorithms themselves are designed by humans whose own assumptions and perspectives can inadvertently shape the AI's behavior and interpretations. We need constant vigilance to ensure AI tools don't simply reinforce old, potentially flawed narratives. Third, there's the black box problem. Some complex AI models, particularly deep learning networks, can be opaque. They might produce a highly accurate prediction or reconstruction, but it can be difficult, sometimes impossible, to understand why the AI reached that specific conclusion. For a field like archaeology, where interpretation and justification are paramount, this lack of transparency can be problematic. Archaeologists need to understand the reasoning process, not just accept the output. Efforts are underway to develop more explainable AI, XAI, but it remains a challenge. Fourth, the risk of overinterpretation and false confidence. AI-generated reconstructions can look incredibly convincing, even beautiful. Generative AI might create a stunning image of a lost temple or a plausible translation of an unknown phrase. However, these are often probabilistic reconstructions, the AI's best guess based on patterns. There's a danger that these compelling outputs could be mistaken for historical fact, especially when shared widely. Rigorous human validation and clear communication about the speculative nature of AI outputs are essential. Fifth, ethical considerations are paramount. Who owns the digital reconstructions of cultural heritage? How do we ensure these powerful tools are used respectfully, particularly when dealing with the remains or sacred sites of indigenous communities? How do we prevent the misuse of AI-generated historical narratives? These are complex questions that require ongoing discussion among archaeologists, technologists, ethicists, and descendant communities. Finally, computational resources and expertise can be barriers. Running complex simulations or training large deep learning models requires significant computing power and specialized knowledge, which may not be readily available to all archaeological projects or researchers, potentially creating a digital divide within the field. Despite these challenges, the trajectory is clear. AI is poised to become an increasingly integral part of the archaeological toolkit, transforming how we discover, analyze, and understand the human past. What does the future hold? we can expect more sophisticated and integrated AI systems. Imagine AI platforms that seamlessly combine computer vision for site analysis, NLP for text decipherment, machine learning for artifact classification, and generative AI for reconstruction, all within a single workflow. AI could analyze data in real time during an excavation, helping archaeologists make informed decisions on the spot. The link between AI and immersive technologies like virtual and augmented reality (VRR) will likely deepen. Archaeologists and the public could soon walk through dynamically generated, AI-powered reconstructions of ancient environments, interacting with simulated inhabitants and testing hypotheses in ways never before possible. Imagine a classroom where students don't just read about Pompeii but virtually experience the moments before the eruption, with the environment dynamically reconstructed based on the latest data and AI models. AI could enable hyper-personalization of historical exploration. Based on your interests, an AI could curate virtual tours, highlight specific artifacts relevant to your questions, or even generate narratives focusing on aspects of ancient life you care most about, say, the role of women, the development of specific technologies, or the impact of climate change. We might also see AI playing a bigger role in preserving cultural heritage. AI can monitor satellite imagery to detect looting or environmental damage at archaeological sites, automatically analyze the condition of artifacts, and even assist in digital preservation efforts, creating detailed records and reconstructions before information is lost forever. Perhaps most excitingly, AI might help us ask entirely new questions about the past. By revealing complex patterns and correlations across vast datasets, combining archaeological evidence with climate data, genetic information, linguistic analysis, AI could uncover connections and driving forces in human history that we haven't even conceived of yet. It might help us understand the universal factors that lead to civilizational flourishing and collapse, offering lessons relevant to our own time. The quest to understand our past is fundamentally a quest to understand ourselves. Lost civilizations hold clues not just about history, but about human ingenuity, resilience, social structures, and our relationship with the environment. AI, for all its complexities and potential pitfalls, offers a powerful new lens through which to view this vast, fragmented record. So we've journeyed from the dusty fragments of antiquity to the cutting edge of artificial intelligence. We've seen how AI is helping archaeologists decipher ancient scripts, map hidden cities from space, reconstruct shattered artifacts, simulate bygone societies, and even predict where history might still lie buried. Techniques like machine learning, NLP, computer vision, and generative AI are not just novelties. They are becoming essential tools, augmenting human expertise and allowing us to process and interpret the remnants of lost worlds on an unprecedented scale. Of course, the path forward isn't without its hurdles, data limitations, potential biases, the need for transparency, ethical considerations, and the danger of mistaking AI's plausible guesses for definitive truths are all critical challenges we must navigate responsibly. AI is a powerful tool, but it remains just that, a tool, guided by human questions, expertise, and interpretation. But the potential is undeniable. By harnessing the power of AI, we stand a chance to piece together the human story in richer detail than ever before, connecting with our ancestors across the millennia and perhaps gaining vital insights into the trajectory of human civilization itself. AI isn't just predicting the future, it's helping us rediscover and understand our shared past. The digital dig has truly begun. What do you think? Are you excited about the potential of AI in archaeology? What lost civilization would you most like to see reconstructed using these techniques? Let me know your thoughts in the comments below. I love reading your perspectives. If you found this journey into AI and the past fascinating, please give this video a thumbs up. It really helps the channel. And if you haven't already, make sure you subscribe to AI Pulse Trends and hit that notification bell so you don't miss our future explorations into the world of artificial intelligence. Thanks so much for watching, and I'll see you in the next Pulse of AI Innovation.